What is up, guys? Welcome back to the channel. Today we've got something very special for you. We're going to go see someone that has helped me an incredible amount throughout my racing career in terms of advice and just general work that he's done for me. Him and I, we've also kind of studied together and we worked together many years ago, and he's been a big help and a big inspiration in many ways in my life. So we're going to go and have a long chat with him, go to his shop and see what he's up to, and hopefully get some more tips and tricks from the guy, and that can help both you and me going forward. So let's check it out. See you there. Alright guys, so we have arrived. We are here. Check this out. Toyota V8. What is this? Cantwell Race Engines. Oh damn. How's it, Rob? How are you, brother?
How's it, Chuck? How are you doing?
Okay, good, man. So, what do we have here? This is your shop, eh?
This is Cantwell Racing Engines, and
awesome.
Yeah, we share with another partner, Matthew Nash, where these are where the Nash sports cars are also built, and side by side we in this factory here in Kaya Sands.
Yeah.
And this is where all the action takes place.
Awesome, awesome, brother. Let's have a look around.
Yeah, so let me take you in here. So Matthew preps a lot of single seaters.
Okay.
Both classic and of the current Formula 4 Duratec's.
Yeah.
We also Matthew builds his Nash sports cars.
Yes,
so
yes.
That's sort of this half of the workshop.
Alright.
You see a lot of the cars are out for racing this weekend.
They're racing at Red Star.
Yeah, they're at Red Star. And there's a lot of the single seaters. Here's some of the sports cars over here.
Right.
And in the far end we've got the fabrication side,
okay,
where all our fabrication work is done, and then just to the right of that, behind the screen here, is our machine shop, where the lathes and milling machines are for all the other bits to complement the fabrication side.
Okay. Rumor has it that you have a dyno, an engine dyno?
Yes, we do have an engine dyno.
So I know, I'm not sure if it's operational or not, but if you want, chat to Robert. I'm sure we can hook something up, or he can hook something up for your engine. Cool.
Definitely.
Tasty VQ37 over here. Very nice.
Actuator here actually got an enormous servo motor on the back here, and by varying this position of this shaft here will determine how much valve lift the intake's opened. So at some point it'll be at full lift under a full throttle applications, about 10 or 11 mil lift, and then it's sort of a closed or cruising throttle where it's like maybe 10 or 20% throttle opening. This will actually pull back to where you only get maybe 2 or 3 millimeters of valve lift, just for economy and emission standards.
Yeah, I've seen some guys try to fiddle with these, the turbo applications, and they actually leave the variable valve lift and timing on.
Right guys, so over here we've got, this is my section here where we've got a lot of the engine build side.
Whoa, Rob! There's a Beams engine.
Yes, we've got a Rally S2000 Beams engine, which
Whoa.
Unfortunately this one has dropped a couple valves.
Okay.
So we will try and fix it. Still got all the fancy carbon fiber covers. For
so
the
I see
motorsports.
Magnesium pulley.
That's it.
Carbon fiber covers. Damn.
Yeah. So unfortunately that one's seen better days. We've got another donor engine here now for parts for that engine,
right,
which is again the 3S GE. These are becoming a lot harder to get these days. So we do use some of the scrapyard base components, but everything else, the important parts, valves, pistons, rods, are all brand new parts that we import.
So this is the Beams version of the engine, is that right? that has the variable valve timing.
That's correct. It starts out from what you would get in the Japan format with the variable valve timing on both intake and exhaust. This is what they call the Beams engine with dual VVT. There was a single VVT variant and obviously non-VVT variant.
So that motor destroyed itself. Huh?
Yeah, we had a dropped valve with we used the titanium valves in that engine just because they're a really good lightweight valve, but unfortunately they aren't as strong as the stainless valves, and every now and again we do have the mishap of dropping a valve. Unfortunately, what we end up with is a piston that looks like that. Unfortunately we can't do anything with it, and that piston is destroyed. And the unfortunate thing as well is that you'll see with the amount of pieces that fly around the engine is that it actually goes back up into the plenum chamber and then down the other trumpets, and it actually ends up damaging the other pistons. So where you've got a dropped valve on one cylinder, if you don't stop it as soon as possible, you end up with all other pistons also getting damaged.
So tell us about these cams. I see there's a very nice set of cams lying here.
Yeah, so these were the 3S cams we used with the rally cars, and for a long time we used the billet. It was a Ken Cam's billet camshaft. It was a very a nice cam by itself with a lot of weight reduction already in the nose of the cam to lower the mass of the inertia and the mass of the engine.
Right.
That was very good for a long time, and then about 2008 we had a few cams come out with this black coating, which is actually what they call a DLC coating, which stands for diamond-like coating. This allows us to further reduce the engine losses. It's a very low friction surface. It's very hard with a very low friction property to it. What helps us is that because the surface is so hard, we can actually reduce the width of the lobe by quite a bit. Because of the hard surface, we can increase the surface pressures. We don't have any breakdown of the materials on the bucket or the lobe, so we go to a very thin cam lobe. That helps us further with with the losses in the engine. So where we would have had a standard lobe or that we were using, we would then further reduce it by, that's almost 2.2 millimeters that we went thinner on the lobe.
Wow.
So about 20% less width in the lobe. If you didn't have the coating, it would run for a short period of time and then pick up on the bucket, and that would be the end of it. So some really nice technology that we could incorporate there.
Okay, so let's just talk quickly about obviously at very high RPM, very high lift cams, you need very strong valve springs.
Yes.
Right? Does the mass of the stainless steel valve affect that versus the titanium valve? Is that one of the advantages of titanium valves?
Yes, certainly the lower the weight, the lighter you can make the valve train, the better. There's a lighter valve, obviously you can control it better with the valve springs, which keeps it in contact with the cam and the lobe, and you don't end up getting a valve float where you lose control of the valve and then it ends up collecting with the piston in an uncontrolled state.
Yes.
I do have some scale here, and we can see the difference in the weight of valves of the similar engine.
Yeah. Let's check that out.
So here we got two sets of valves, essentially an intake and exhaust. One of them is a stainless steel valve and the other one is a titanium beams valve. They are pretty much of the same length and diameter, both intake and exhaust. as you can see here, they are pretty much size for size.
Sure.
And we'll just show you the difference from a stainless valve to a titanium valve. So there we got 40 grams on the stainless valve, and then with similar size the titanium valve, we've got 16 grams lighter. So
wow.
Not quite half, but a good 40%
Yes,
lighter.
yeah, 100%.
And then the same for the intake valves. We've got what do we got there? 50 grams on the stainless intake, and then when we go to the titanium intake valve, we got 50% weight reduction. This was a standard OEM Toyota part that came out in the Beams engine. Nothing special.
Okay, beautiful. So I see you got some nice pistons here, Rob. Tell us about what's happening here, brother.
Yeah, so we just actually, before we do the assembly of the engine, we're just balancing the piston set and the rod set. They have been balanced before, and they would have been balanced when they come from the manufacturer. We try and get it absolutely spot on. So between the 4 rods, we're looking for a half a gram, a quarter of a gram. You juggle them around so that your 1 and 4 cylinder is equal to your 2 and 3, because that's in the reciprocating engine. You want the 2 cycles to be balanced, and if there is a means where we're 1 or 2 grams out, we can swap them around and get it that we're exactly equal. And again, that's all balancing of the engine. There's all little bits to be made up on the power sheets with getting it all balanced. Yeah, so just lastly, I've got a few bits here. These are just a few other engine bits where over the years being involved with the national rally scene, we've been subjected, or we've been very fortunate to play with some really nice toys and all that. This again is the S2000 category that I was involved with. This was Ford Fiesta S2000, built by M Sport. And it was a 2-litre Duratec engine, and these not getting the power that we needed, we had to do a lot of modifications. So we went to a loose sleeve or liner, and again you can see just in the manufacturing of this liner how they will waste as much material away, keeping the top as thick as possible, but then getting rid of any material that's not necessary. This keeps the top of the liner very strong and stable, but as soon as the combustion pressures and the clamping forces have dissipated further down the sleeve, we get rid of it until we need to pick up again on it. So these were the liners we used. We used a very fancy Marley piston that was manufactured for these engines. It's an all anodized engine. You can see that we've obviously over the years we've cleaned a bit of the anodizing off. Just getting back to the cams and the valve train, where we saw the lighter weights of the valves, of the titanium valves. I've got 2 valve springs here. And this is sort of your conventional valve spring that you would see, where it's a parallel spring. It's a single rate valve spring, and in these engines we'd use a conical spring. And 2 reasons for that is one, if we can reduce the top of the valve spring, we get away with a really much smaller valve retainer, which reduces weight. And the other big thing which we curb with a tapered or conical spring is that it's no longer a set spring rate. This has a difference in spring rate, and therefore we don't develop a natural frequency, and we don't get a bouncing of the valve spring. So 2 things there that we gain.
Alright, let's chat a bit about these valve buckets, these DLC coated buckets.
Yeah, so most engines we use, if it's not a rocker engine, we're using a bucket. This is pretty much the bucket that you'll mostly see, which is just a round flat top bucket. In these fancy engines that we were involved with, again, we've got the DLC coating, and the fancy part about it was in this engine we went to a convex shape on the bucket instead of the flat top. It's got a pronounced convex on the bucket, which allowed us to get more around the rules, where we're only limited to 12 millimeters valve lift.
Yeah.
This completely changed the geometry and the profile of the cam, and allowed us to accelerate the valve open to 12 millimeters as quick as possible, hold it for as long as possible, and then close it.
So Rob, I see you got a nice freaking gearbox here. Tell us about it, bud.
Yeah, this is a really nice Ford Type 9 gearbox. It's based on a Type 9 gearbox. They came out with cast iron housings. This is a reproduction by Quaife, aluminium housing. Really nice. It's a straight cut kit. Ratios are optimized for the customer, for his application. It does a lot of hill climbing. So it's a very close ratio kit. This is still a synchro box. It's still got the brass synchro rings, but it is a straight cut. So you get 3 odd different types of gearboxes. You get a straight cut, which this is. You get the road going car gearbox. It's got a helical gear to it, and those are sort of the two between those. And then on top of this, the sort of the other variant is a dog gearbox, where it gets rid of the synchro ring and you got the dog teeth. There's no slipping or anything. It goes in there and engages, locks up, and that's it. So this would be a straight cut dog gearbox. This one,
Alright.
yeah.
That's for sale.
Yes, it is.
Contact Robert.
Hi guys, so here we got the engine dyno. I think a lot of you guys have seen the chassis dynos, where you put your car onto a set of rollers to measure the torque and the power of the car. This is very different. This literally is just for the engine, to take a torque reading and RPM reading off the back of the flywheel of the engine. It's a very basic device. It's literally it's a water brake, which we pump a certain amount of water in to hold the engine at a static RPM, and then with that static RPM sort of obtained, we take a torque reading through a strain gauge load cell, and from that we know exactly at, say, whatever RPM when we're going through the RPM range, we know exactly what torque the engine produces, and all your other losses are taken out of it. Gearbox, tires, drive shafts, that's all taken out of the equation, and we know exactly what the engine makes. It's very good for engine development, because you remove so many variables from it. It's as simple as that. They are very sensitive tools for measurement, but it's a very basic tool for just literally torque.
Let's talk quickly electronics, Rob. I see you're busy with some good stuff here.
Yeah, we also do, amongst everything to complement the engine side and the gearbox side with the cars, is we're involved with wiring. It's obviously wiring electronics is a huge thing in motorsport these days. So this is a Motec system that we're busy installing into this car. It's a custom built harness. We got all the every sort of connector's got its sort of label and its home. so that when the customer gets it, he knows where to plug it in.
Yeah.
There's no question of which connector goes where, and yeah, so that's all the fun parts of motorsports. It's really important that guys get more familiar with the electronics, because it's just more and more with the motorsport these days.
Yeah, especially these Motec systems. I mean, there's so many systems available now. AEM, freaking Motec. There's so many. The Motec, the guys love Motec obviously because it's so expand.
It's a brilliant product. This unit here is got it's a full open box. It's got traction control, launch control, knock control, land control. It's got every control you can think of. You can run nitrous on it, variable cam timing. They're incredible, the amount of power and control you have with these ECUs.
All right, Rob. Well, thank you for your time, brother.
Awesome. Guys, thanks so much.
If you guys want any engine work done, where can they get hold of you, Rob?
Yeah, we've got a Facebook page, Cantwell Racing Engines, which got my contact details on it, and or you'll find me at the track or in the off-road scene. Just come look and see if you can find me. Give Jacques and myself a high five and a thumbs up.
Awesome. Thank you, guys. Thank you, Rob. Thank you guys very much for watching. If you like this, hit the like button, maybe you can subscribing, and we hope to see you guys soon. See you later.
Cheers,
Ciao.
guys.